This video will cover the Unit 7 topics in intermediate algebra on transformations of functions. We're going to be referring to this Hicks-Voy thing a lot throughout this unit, and that's going to help us in remembering what type of transformation is occurring and how it's affecting the graph or the x and y values. And so Hicks-Voy stands for horizontal, meaning left and right, inside the parentheses, and it affects the x's. Vertical goes up and down, and it's found outside the parentheses, and it affects the y's. We're going to jump right into the review, but you have this study guide to help you out if you're stuck or if you're not understanding something that I may have said. Remember that at any point you can pause or rewind the video so that you can help yourself be successful. Alright, so number one is just a basic transformations description. So we're going to use Hicks-Voy a lot here. If I have a +1 on the inside of parentheses, that means it's Hicks, which means that we can move right or left. If it's inside the parentheses, we actually do the opposite. So +1 typically means move towards the right, except this time we actually have to move towards the left. Again, when we move, shift, up, down, left, right, if we're talking about left and right, it's the opposite direction of the sign. The next one, we have a 3 on the outside of the parentheses. So this is a Voy problem. If we are multiplying by 3, think about taking your body height and multiplying it by a factor of 3. Are you stretching or compressing? So if I'm taking my body height and multiplying by a factor of 3, that is a stretch. If you guys have seen those Stretch Armstrong little figurine things, not even figurines, they're the coolest things in the world from like the 1980s. Here you go, here's what Stretch Armstrong is. So this little guy can be stretched either horizontally or vertically, but think about taking him and stretching him tall. So if I take him and stretch his height, kind of like this little picture that I drew over here, oops, you can understand that he's being stretched, just like his cool name, Stretch Armstrong. Okay, now the next part, we have a 1/3 in front of f of x. 1/3 is outside the parentheses, so that's Voy. Remember, Voy, outside O. So instead of compressing, or instead of stretching, I'm taking my body height and multiplying it by 1/3, which means it's actually getting shorter and like wider. So this is called a compress. The next one, we have a negative on the inside, so that's a Hicks problem. This one actually really helps if we have a little visual. So I want you to get in the habit, if you see a negative, take and draw this little blob on an XY axis. Because it's a Hicks problem inside the parentheses and we're changing the x's, if I want to change the x's go in the left and right direction. So currently I'm in positive x's with a red, but I want to change them to negative x's. So my little blob's going to move towards the left. But as I do that, I'm doing a reflection over the y-axis. I'm negating the x's by reflecting over the y-axis. In the next problem, part E, we have the negative on the outside, so that's Voy. Voy affects the y's. Again, get your little blob going. Think about positive y in the red going down to negative y in the blue. So when we do that, it flips or reflects over the x-axis. Again, these pictures that we just drew, those little blobs, they are very, very helpful when you think about reflections, as in D and E. And the last one that we have here, this +1 on the outside of the parentheses, this is another Voy problem. We're changing the y's by adding 1. So this takes us up 1. So we're going to see a couple examples, and apparently Stretch Armstrong is going to follow along with us. Let's see if we can get rid of him. Goodbye, Stretch. Okay, so example 2 says the graph of f of x is shown below. And we are trying to first describe the transformation that's occurring. So we have a -2 on the inside, that's a Hicks problem. And we have a minus 2 on the outside. That's a void problem. However, remember when we add or subtract on the inside, we do the opposite. So typically minus means to the left, but we're going to actually go to the right. Right 2, and because it's minus in the y direction, we go down 2. So for part B, where it says sketch the graph of g of x, you're literally going to take each point, move it to the right 2, and down 2. So I'm taking this point right here, going right 2, 1, 2, down 2, 1, 2, plot the new point. Then move on to the next one. Right 2, down 2, plot. Move on to the next one. Right 2, down 2, plot. So on and so forth until you are all the way done with all of the points and you have connected to make the new function g of x. Now the next part says evaluate g of negative 3. That's an x value. Negative 3 is an x value. So what we're going to do is go to the graph. We're going to look at the x-axis because we're talking about x values. We're going to go to the left 3, negative 3. 1, 2, 3. And I'm moving now down towards the g of x function, my blue one. I don't want to go upwards because that's the old function, f. I want to go downwards, and I'm going down to negative 1, which means that g of negative 3 is equal to negative 1. So let's try g of 4 then. Remember, this is an x value, so go to the right 4. 1, 2, 3, 4, and we land at 0. There's no ups or downs here, we're just right there at 0. So g of 4 is equal to 0. We're going to take a look at number 3 here. It says that we need to describe the transformation happening if g of x is equal to negative f of x. The negative is outside the parentheses, which means that we are using void. Guess what? Here we go with our awesome little blob picture. So here's my blob. We're affecting the y's. Y's go up and down, which means that this blob needs to move down. So when I describe this, this is a reflection over the x-axis. So when we reflect over the x-axis, sometimes it's helpful to highlight it or color it or do something to make it stand out to you. Because what we're going to do now is make a mirror image, essentially, of the function that's already there to make a new function, g of x. So we count boxes. This first point is one box from the red line, from the x-axis. So I want to do the same thing on the other side. Count one box away and plot the point. Now you don't have to draw those little jumps. It's just for me to help you to see what I'm doing. The next point right here is 1, 2, 3 away. So we must go 1, 2, 3 beyond. You count the same number of boxes on both sides of the line. The next point still again 1, 2, 3. So we go 1, 2, 3. And moving forward, we are 1, 2 away. So we 1, 2 away. Now again back to 1, 2, 3. 1, 2, 3. And we're going to connect. And remember to label this as g of x. The next part says evaluate g of negative 1 and g of positive 2. Remember, both of these are x values. Go ahead and try to locate their y values on the graph. And you should be thinking to yourself, do I want to go up to the black graph, what was already there, or do I want to go down to the new graph, what I just plotted? Hopefully you're saying go down, go down, go down. Okay, we need to go down to the green or the blue graph, sorry, the g of x graph, because we're evaluating a g function at the value of negative 1. So if I go left 1 and then down, we land at negative 3. If I go right 2 and then down, we land at negative 2. Go ahead and flip it once you have it. Number 4, another description, graph, and evaluate question. It says describe the transformation to f of x if g of x is equal to 2 times f of x. 2 times the function. That's void, because it's outside. And if we're taking and multiplying by 2, think of your body height getting multiplied by 2. You get stretched. Okay, so this is a stretch by a factor of 2. Graphing this is a little bit weird. Essentially what we're doing is doubling the distance from the x-axis. Doubling distance from the x-axis. Now, it's not always doubling. It depends on the number that you're multiplying by. If it were a 3, we'd be tripling. If it were a 4, we'd be quadrupling. If it were a 10, I don't know the phrase for that. Okay, anyways. So what we do is we take a look at, say, the first point right here. And it's currently 1 away from the x-axis. But I want to double that distance. So 1 away times 2 now means that I should be 1, 2 away. So I'm going to plot the new point at 2 spaces away from the x-axis. The next point is 3 away from the x-axis. So now to double that distance, I need to go another 3 away, or a total of 6 away from the x-axis. The next point is actually at the same height. Started at 3, 3 times 2 means I'm 6 away in total. The next one we're up at positive 2, so instead, positive 2 times 2 means my new graph is up at positive 4. My next point here on the very end is up at positive 3. Double that distance, so now we're up at positive 6. And we're going to connect. And this is g of x. So when we're asked to evaluate, it's the same process. Remember to look at your brand new graph. So we have g of negative 1 and g of positive 4. Go ahead and evaluate independently on your own right now. You should actually get 6 for both of them. That's because if I move to the left one and up, up, up to my new graph, I'm at 6. If I move to the right 4 and up, up, up to my new graph, I'm at 6 again. Number 5 is getting us to look at even, odd, and neither functions. And if you look at your study guide, it explains what even, odd, and neither are, but I'll explain them to you real quick. Even is symmetric about the y-axis. So something like this graph would be even. Your basic parabola. Y equals x squared. Because it's reflected over the y-axis to map on top of itself. It's symmetric through the y-axis. An odd function is symmetric about the origin, meaning that it can be rotated 180 degrees to look like itself. So an example of an odd function would be a cubic equation, something like this. Y equals x to the third. Because if I were to rotate that 180 degrees, let me see if I can do it here. 180 degrees shows me the same exact graph that I had just drawn, the little cubic equation. Now, if you have a function that is not symmetric about the y-axis, nor is it symmetric about the origin, then it's called neither, or neither, however you say it. Tomato, tomato, I suppose. Neither means that it's not symmetric about the y-axis, nor the origin. Now, that's not to say that it can't be symmetric. It can absolutely be symmetric. It's just not symmetric about the y-axis nor the origin. So if I were to look at this graph here and try to see its symmetry, it's clear to me that the y-axis